Hello, this is the 2015 exam 2. I'm recording, yes. So this is the networks question 3. We have a table there with some durations, ESTs, predecessors. We have a diagram, cool. Delivery of groceries from factories to towns and the duration in minutes. So there we go, that's what this is. EST of activity D. Activity D is this one here. It can begin after B, which is going to take 3. The LST of activity D. So we should determine, well, finding the critical path is going to be useful. We know the minimum completion time is 26 minutes, which I guess is helpful. AC takes 13, BD takes 12, so the AC route is critical. EG takes 7, the I is going to be critical. So AC would take 13, plus 7 would be 20, plus 4 would be 24, which means that's not critical, and so this must be the critical route. And so AC takes 13, F takes 6, which is 19, I takes 4, which is 23, which means that H must have a duration of 3 to have a total minimum completion time of 26. So that's that. So from there, and we didn't need to do all of that to find the float of activity D, or the LST, but you know, it's going to help in a second, probably. So AC took 13, BD takes 12, which means that D has a float of 1. And so since the EST of D is 3 and it has a float of 1, the LST must be 4. Given that the EST of I is 22, what is the duration of H? We've already figured that out. Write down in order the activities on the critical path. Again, already figured out. AC, FH, I. Activity C and D can only be completed by either Cassie or Donna. One Monday, Donna is sick, and both activities C and D must be completed by Cassie. Cassie must complete one of these activities before starting the other. Yep, makes sense. What is the least effect of this on the usual minimum completion time? Okay, so activities C and D must be completed by the same person, and one must be completed after the other one's finished. All right. So if we were to start activity A and B at the same time, B would finish after 3 hours, and then we could get Cassie. I think it's Cassie. Yeah, Donna's 6, so Cassie. Cassie would immediately start on activity D after 3 hours and would finish after 12 hours. So B and D would finish after 12 hours, by which time activity A has been finished for 7 hours, and just, you know, activity C is sitting there waiting. It hasn't been done yet because Cassie has to do it. So activity A will finish after 5, B and D will finish after 12, and it's almost like I've got a dummy going back to make the end of activity D a predecessor for C. That's almost like what's happening. All right, so BD takes 12, and then I start C, which takes 8, and so that would get me to this point here after 17 hours, minutes I think, right? I think it was minutes. So it's going to take 3 plus 9 is 12, and then I start the 8. So that's going to be 3 plus 9 is 12, plus 8, where did I get 17? Sorry. 3 plus 9 is 12, and then the C activity, which is 8, which would get me to this location at 20. Originally, I got there at 13, and so the effect that this would have would be a delay of 7 minutes. Delay of 7 minutes. That's it. A little bit tricky. Every Friday, a special delivery to the 5 towns includes fresh seafood. This causes a slight change to activity G, which then cannot start until F has been completed. That's fun. Show this change without duplicating any activity. Okay, so what it's saying is we want to draw on the diagram that G cannot start until F has been finished, so we're just going to put a dummy. That's it. And what effect does this have on the usual minimum preparation time? So again, looking from this point to this point, originally it took me 9, so H was 3, so it took me 9. Now it's going to take me 6 plus 5 is 11, so it's going to delay by 2 minutes. And that's it, I think. Yep, that's the question. So yeah, hope that helps, and I'll see you in the next one.